In this class, I'll be taking you through augmented nonlinear LDL model. So let's assume we have a variable exchange rate, which is assumed to be asymmetric. And note, this exchange rate is the target variable, that is the target explanatory variable, or if you like, independent variable. So we have specified our model in logarithmic form. So here is the model, NARDL is specified as this. So we have the log of real GDP as the dependent variable. Then we have log of exchange rate is partitioned into two because it is assumed to be asymmetric. We have positive changes in exchange rate and we have negative changes in exchange rate. Then we have the control variables that are assumed to be symmetric. They are not asymmetric. That's why they are not partitioned. We have inflation and trade openness. So these are the definitions of the parameters and variables we have in our specification. So we can also see that the exchange rate is decomposed as this because we believe exchange rate is asymmetric. Okay. Say we can go through it where the log of exchange rates positive to represent the cumulative positive changes. That is exchange rate appreciation or depreciation, depending on the definition of our exchange rate, that's how we quote our exchange rate. So we also have negative changes in exchange rate. Okay, that represents cumulative changes, cumulative negative changes in exchange rate anyway. So the corresponding in NARDL bond test model, also known as the unrestricted error correction model for NARDL, can be specified as follows. So we have this. You can see we have the coefficient of the lag dependent variable. Then we have exchange rate that is partitioned into two. We have positive exchange rate and we have negative exchange rate. You can see there is positive changes in exchange rate and negative changes in exchange rate. You can see that is the only difference between the traditional RDL and non-linear RDL, that asymmetric RDL. You can see the exchange rate is decomposed into two components, positive changes and negative changes. You can see, okay, and these coefficients, you can see these coefficients pi1, pi2, pi2 positive and pi2 negative. This represents the coefficient of interest here. We also have the short run coefficient here, okay, short run coefficient here. So here we have augmented bond test. So these are the tests we are going to carry out on the coefficients we estimate here in bond test model. Okay, so we are going to test whether pi1, pi2 positive, pi2 negative, then pi3, pi4, all of them are simultaneously equal to 0. If any of them is not equal to 0, so we are going to reject this non-hypothesis. Okay, you can see that is what we put there. So we are going to use F-test on all these parameters I just mentioned, pi1, pi2 negative, pi2 positive, then pi3, pi4 equals 0. If we reject this non-hypothesis, okay, it means there's likely to be a long-run relationship, okay, although we have not confirmed that yet, okay, because we still have other tests, okay, that this model must pass. Okay, we also have t-test on the lag-dependent variable. We are going to exclude other parameters and we focus on pi1. We are going to test whether pi1 is equal to 0 or is not equal to 0. So we also expect to reject the non-hypothesis. If we reject the non-hypothesis, then we are likely to have long-run equilibrium, or that's long-run relationship. Okay, this is additional proof that there's likely to be long-run relationship. And finally, okay, we are going to test other parameters, excluding the coefficient of the lag dependence, which is pi1 here. We are going to test whether this okay, are also equals to 0 simultaneously, or at least one of them is not equal to 0. Okay, so if we reject the non-hypothesis for all these three tests, so we can confidently conclude that there is long-run relationship. Okay? But if we cannot reject any of these hypotheses, okay, even if this is one of them, okay, there is no evidence of long-run relationship among these variables. Then this is if we are able to establish uh, long-run relationship based on these three tests. So we can now estimate this model, that is our error correction model. Okay, this error correction model will include both the short-run coefficient, okay, and the error correction term. Okay, and the error correction term will carry the speed of adjustment. Okay, the speed of adjustment here is this side here. Here is the speed of adjustment, and this is error correction term. Okay, and the coefficient we have here like beta 1 and like beta high here, negative, beta high, positive. We have a theta high, we have alpha. This represents the short run coefficient. Okay, so short run coefficient. Okay, and this ECT, that is the operation term, and this psi represents the speed of adjustment. Then all these components, all these parameters, and the error correction term are defined as are defined the same way we defined them in our previous classes. Okay, now the next thing is to specify the long-run NARDL model. This is the corresponding NARDL. The only difference between this long-run NARDL model and traditional symmetric NARDL model is that we only partition the asymmetric variable. You can see that is exchange rate, we partition into negative changes and positive changes. That's the only difference. And the parameters are defined as this. Okay. Then lastly, we have asymmetric test. We need to test whether there is existence of asymmetry, or that is the essence of using NARDL. That is whether positive changes, okay, has different effects from negative changes on the explanatory variable. Okay, so that is whether the magnitude of the effect of the positive changes on the dependent variable is different from the magnitude of negative changes in the independent variable on the dependent variable. Okay, that is that. You can see we are going to test the short-run coefficient. Okay, the action of the short-run coefficient that this beta high positive, the sum of this beta high positive, whether is equal to the sum of beta high negative. Okay, where is that coming from? That is coming from our bond. That is coming from our estimated model. Okay, it's coming from our estimated model. You can see here. Okay, you see we have this, the short-run model. You come here. This is our short-run model. We have a short-run model here. Okay, like I said. So what we are testing is this. We are testing whether this beta high positive, the sum of this is equals to the sum of this. Okay, okay, statistically. Okay, if we reject the non-hypothesis, okay, that they are equal, okay, we conclude there is asymmetric short-run effect. That is, in the short run, there's asymmetric effect. Okay, that negative changes and positive changes effects are not the same in the short run. That's what it means. And for the long run test, okay, long run test, we are going to say beta 1 plus beta 1 minus. Okay, so where is that coming from? It's coming from the long run model. You can see we are testing whether this beta 1 plus is equals to beta 1 minus, okay, negative. Okay, if you reject the non-hypothesis A, it also means there is long run asymmetric. That is the positive changing in exchange rate in the long run. Okay, the magnitude of the effect of the positive changes in exchange rate in the long run is different from the effect of the magnitude, effect of the negative changes, okay, on the dependent variable in the long run. Okay, that's what it means. Now, let's move into STATA. Let's move into STATA now. In the STATA environment, so let me set my working directory as usual. I say wherever you are in hub, you are advised to first set your working directory to the right folder. Okay, so let's do that. Let me locate the folder where I put all my necessary files I want to use. Okay, so I put it in. So I have economic tutorial. Okay. Yeah, this is where I put it. Then I've set my working directory. Now let me go and open the do file I want to use. You can see because I've set my working directory, okay, using the folder where I put all my materials, my do file. Once I click open in STATA environment, it takes me directly to that folder. So now I want to carry out NARDL movie. Okay, you can see this is the do file we are going to use. Then I click open and I wait for the do file to open. Here is the do file. Okay, yes. So the next thing I'm going to import the data set. Okay, let me import the data set. So I'm going to do that manually. So import data set, then it's an Excel file. I click on Excel. Then I click on browse, take me to that working directory. You can see this is data set, data one. Then I click open. Then I check this first box, import first row as variable name. Then I click OK. Then I go back to my do file. So wherever I want to carry out the analysis, that's whether ARDL or NARDL, okay, the first thing is to declare my data set as time series. To do that, here is the code TS set year. Here is the variable name, okay, the variable name for the time period, okay. So you may want to view the data set, okay. If I want to view that, just type B and that is browse in full. This is that. So this is yeah, time variable year. So that's what I'm going to use. Okay. Now moving back to do file. So let me declare the data test as time series. So let me run this. So I've declared my data set as time series. You can see I have from 1981 to 2023. Then the next thing, because I don't need this anyway, okay? But because this is, because in my specification, model specification, I have the log of GDP and log of exchange. So I want to generate log series. So let me do that. Generate the log series. So I'm not going to generate log series for trade openness and inflation because those variables are in percentage and we don't log variables in percentage, okay, because they are already in percentage. So the next thing I'm going to do now, is to estimate the model. Okay, this descriptive statistic, I'm going to jump it, okay, because that's not the focus of this class. Okay, but if you are interested in just run it. Okay, now the command we have been using is AARDL. Then we are going to put the dependent variable first, followed by the key independent variable. Then we have two control variable, comma, type. You can see NARDL, that's the name of the model. Then we have decompose. What variable is assumed to be asymmetric? That's the log of exchange rate. Then we usually set the maximum lag. Okay, we use the default for. So this AIC is still default. If I don't put it, my result is going to be the same. Then the popular case, which is case 3, that's unrestricted, intercept, and no trend. Okay, now let me run this. So let's see. Let's wait for the result. Here, before you interpret your results, okay, before you interpret you have a few things you need to pay attention to. So I will have mentioned this when we are running augmented RDL mode, okay, but this is too useful. Okay, the first thing, whenever you run NARDL model or NARDL model, the first thing you are meant to check the diagnosis test. Okay, especially if there is serial correlation. Okay, if there is serial correlation. Well, if there is serial correlation, the result of your bone test will not be valid. Okay, so here we have diagnosis test. So there's no serial correlation anyway. Okay, what we have misspecification issue here. Okay, that's the misspecification issue here. So this is another issue. So we not like to leave it like this. We may want to correct for this. So how do we correct for this misspecification? Okay, so we want to ensure that we have everything. Okay, at least it's only Jacobian statistic. If errors are not normal now, we have a data set that's large, especially if we have the sample that's greater than 30. So we may not worry about this non-normality of the errors. Okay, but at least there will be no serial correlation homoscedasticity misspecification issue. Okay, so this one is general, but for one test, the only issue, the key issue is that we shouldn't have serial correlation. Okay, and this met that condition. In order to not to rerun our model later. Okay, let's quickly correct for this miscalculation error now. Okay, so the ways to control for this miscalculation error is that you can either reduce the lag, okay, your maximum lag, or you increase the maximum lag. Okay, so if you reduce maximum lag and it's not corrected for, you can now increase it. For example, I'm going to change this to 3, the maximum lag. If the miscalculation issue is not resolved, I will now change it to 5. Okay, so now let me run that and see whether it is corrected. So let's wait and see. I think it is corrected now. Now let's look at it. Yes, you can see even it's even corrected. The non-normality is even corrected. You can see we have our diagnosis test. Okay, telling us that these estimates are reliable. Okay, no non-normality. So errors are normal. We are happy. No serial correlation. We are happy. There's almost the rest of the error. We are happy, and the model is now correctly specified. So we are happy. So we are good to go. Okay. So you can see here that no serial correlation. We are going to go to interpret our bond test. So let's go to our bond test. You can see for all these 3 tests. Okay, they are significant. The conclusion is that we have a long-run relationship. Okay, among these, you can see a contribution exists. Okay, so now we can now go to our model and interpret. So look at this, the adjustment speed, or we like the speed of adjustment. Okay, so this is speed of alignment. So this is negative and less than 1 absolute value, and it's also significant. So it meets the criteria, all our criteria. It meets all the criteria. So this confirms the existence of long-run relationship among these variables because it meets the criteria. It confirms the result of bond test. Okay, we just interpreted. Now, so the speed of adjustment here is about 18%. Okay, that is if there is a deviation, okay, from equilibrium. If the GDP, okay, deviates from the equilibrium, okay, in previous video, that is in previous year, okay, about 18% of this deviation will be corrected in the current year. So that is what it means. So we also have the positive changes in log of exchange rate. You can see that is not significant. Okay, this is long-run model. Okay, meaning that the positive changes in exchange rate does not have significant impact on real GDP in the long run. Likewise, negative changes does not have significant impact in the long run. Okay, so we can also see why the inflation, the control variable, has significant and negative impact on real GDP, and trade openness is not significant. Okay? The statement does not have significant impact on real GDP in the long run. Okay, all these are the long run. So we have short run. We have short run. Okay, so this is the target variable anyway. You can see we check for the significant coefficient. So if this is significant, this is significant, this is, you can see for all these coefficients, they are negative. Okay, it means that in the short run, positive changes has negative impact, and the positive changes in exchange rate has negative impact on real GDP in the short run. That is what it means. What of these? We also check the significance ones. Okay, none is significant. It means that negative changes do not have significant impact on real GDP. That is, negative changes in exchange rate do not have significant impact on real GDP in the short run. That's what it means. We also check significant coefficients here. It's only this one that's significant, and you can see this is negative. It means inflation has negative and significant impact on real GDP in the short run. Moving to trade openness. So it's only this one that's significant, okay? So meaning that in the short run, trade openness has positive impact on real GDP. Okay, now moving down to diagnosis, the diagnosis test. Okay, you can see we have already explained this before. So errors are normal, no serial pollution, there is almost scarcity, already spent space, and we are happy. Look at this asymmetric. For the long run, so the work test, look at this value, DP value here. So it indicates we cannot reject the non-hypothesis that these beta 1 positive and negative are equal in the long run. So it means the conclusion is that in the long run, there is no asymmetric effect. Okay? That is, there is no point in using this NARDL, okay, in the long run. That's what it means. Let's also check whether it exists in the short run. So the short run also indicates that there is no asymmetric effect in the short run. That is exchange rate does not have asymmetric effects on real GDP in the short run and also in the long run. So the conclusion, wherever you have something like this, if either of these is not significant, okay, if at least one of these is significant, it means that you can still use NARDL. There is justification for using NARDL. But in this case, no asymmetry in the long run, no asymmetry in the short run. So there is no justification for using NARDL in this case. So we can just stick to our ARDL or that augmented ARDL model using all these three tests. Okay, so that is that. So moving down, let's move to this. This is your ECM coefficient, and this is half-life period. So how do we interpret this? So these three, because we are using annual data. So these three stand for 3 years, and we have 4 here. This 4, if it will have been 3.4, it will have been 3 years and 6 months. Okay, but this is not up to 6 months. This is about, let's say this is 3.3 is about 3 years, 5 months. Okay, so it means that if there is a shock to real GDP, okay, so if there is a shock to real GDP, so the impact of this shock on real GDP, the impact of this shock on real GDP, that is the half of the impact of this shock on the real GDP will disappear within 3 years and 5 months. Impact, the total impact, okay, of the shock on the real GDP, 50% of this impact, okay, will disappear. That is, the half of this impact will disappear in 3 years, 5 months. That is what it means. So now that is the interpretation. You may want to look at the beautiful graph that comes with that. So we have persistence. So this line here means where the 50% of the effect of the shock disappears. So corresponding to 3 years and 5 months. Okay, look at here, 3 years, 5 months. You may want to say the asymmetric. Okay, you can see this red line indicates negative shock. The impact, you can see it shows that negative shock has it has a falling effect, that is a decreasing effect, a decreasing impact on real GDP. Okay, while you can see negative changes have a decreasing impact on real GDP, while positive changes has positive changes on positive impact on real GDP. So that is that. Okay, hope you understand this. Thank you. See you in the next class.